All right, so who am I? I'm Richard Bondi. I've been at Google since 2010. I was a dev engineer in travel, and about 3 years ago I decided to do a rotation in SRE, and partly because of the awesome onboarding experience, I decided to stay. The other reason was that they said they'd pay me to write, which I'd always wanted to do. So I'm one of the few SRE tech writers at Google, but they also make me still write code. Okay, so what is this about? It's a summary of a 10,000-word history that I researched and wrote internally of something unusual, how one rollout tool came to be adopted by almost all the SRE teams and many dev teams inside Google. So I'll have to leave a lot out, but the history is supposed to be published externally maybe this year. I'm just not involved, so I don't know exactly what's going on, but that's what I've heard. Okay, what is Sisyphus? Sisyphus is the tool that I wrote the history of, and there's a screenshot coming up soon. Why does it matter? Well, Google has a hard time getting SRE teams to standardize on tools and processes, and I think once your SRE org reaches a certain size, two things are going to happen. Standardization is going to start to matter, and you'll discover that it's hard. So this talk is about that. My idea was, can we learn anything from when it has happened organically? And so I got the okay and went and researched it and wrote it, and after a lot of interviews and a lot of code archaeology, I came up with why I think this one tool got accepted, and hopefully we can learn something from it. So here we go. All right, so it's just a brief overview of the second part of the talk. There'll be a screenshot so we know what I'm even talking about, this tool. There'll be a list of alternatives that did more or less the same thing but never got adopted widely. And there'll be a graph just to prove that I'm not making this up, that Sisyphus is adopted everywhere. And finally, why this crazy adoption is really mysterious. And then I'll give an overview of the rest of the talk. Okay, so this is a screenshot of Sisyphus. It's really just a scheduler. So like that first orange arrow is just pointing at a task, begin, and Sisyphus will just execute each of these tasks, and a task is just a bunch of CLI commands that would be toil for a human to type. And Sisyphus is clever. It can proceed based on feedback, and more importantly, it can also just stop at a certain point and ask for a human to okay whether it should continue. And that's basically it. So it just automates lots of commands that you'd otherwise have to do in different tools and CLIs. Okay, so lots of teams wrote similar programs, and I can't list them because they're all internal code names, but you get the idea. There were a lot of them, and they didn't get adopted the way Sisyphus didn't. So this is a graph to show you that I'm not making up the adoption. I had to do this internally too. There were a number of graphs because you can't just go around saying, oh, everybody uses it. Really? Show me the data. So here's some data. The blue bars are the ratio of commits per author to Sisyphus. So I should explain, Sisyphus is a little bit weird, luckily for me, in that it's not like a service that you just go to a web page and sign up. Instead, you have to subclass the code, build your own binary, and then push it out into production and look after it. It's your own service. What this means is that every SRE team that starts using Sisyphus is going to be committing all year long because their processes change. So it's pretty easy to check whether Sisyphus is being used and by how many people. You just look at the number of commits to it. So the blue bars are the ratio of commits per author, and you can see they stay pretty much the same throughout about 2 years. The orange are the number of commits going up, and that shows us that more and more teams are continuing to use Sisyphus, and what the blue bars show us is that this is not because of a few Sisyphus heroes or like one team with a few people making all the commits. The ratio stays the same, so this is strong evidence that Sisyphus is being adopted by more and more teams, and once they adopt it, they continue to use it. Okay, so if you define success as adoption, there are 3 reasons why Sisyphus's success is baffling. So one is that whatever explains its success, it can't be what a lot of people consider traditional best practices, because Sisyphus violated all of them. Sisyphus had no roadmap, no schedule, no charter, no product requirements doc, no SLO, no defined development process, no clear team, no product manager, no project manager. And the design doc was written about 6 months after the thing went operational. So best practices can't explain why this is a tool that everybody likes to use. Secondly, it can't be code quality, because even the guys who wrote Sisyphus told me in interviews it's just terrible. They feel really embarrassed about it, and it's basically because it's in Python. And when you get above a certain number of lines, debugging Python is just hell. So it's a spider's nest, if there is such a thing, or it's not good. And the last thing that makes Sisyphus's adoption baffling is that it's been around for about 9 years, and through all of those 9 years, SRE leadership hasn't been backing it. They've actually been trying to get rid of it. And this is not because they're evil. They had lots of good reasons. I'll just give you one. One is that, so it grew out of the search SRE team, and the managers on the search SRE team were always short of SREs, and they just got mad because they felt like, why are our SREs, when we need more, spending all their time on this code that all the SRE teams get to use and don't need to spend any time on? That's just unfair. And so they tried to create a separate product with its own team, and it didn't work out. There was one Sisyphus engineer who wrote on the whiteboard behind him, Sisyphus will be replaced by, and then would write the name of some project. And then he would cross it out and write the new one. And this list grew towards the floor over the years. And unfortunately, we don't have any pictures because this was like a year or two after the iPhone. Smartphones weren't a thing. But I've heard this story from more than one person, so it's true. Okay, so the rest of this talk is trying to explain this baffling mystery. And so it's not just my opinion, because in the 10,000 words that I wrote, I try to shovel in lots of evidence for my opinions. They're not just thoughts. Here I'll just have to sketch that. Notice that the problem I say is an adoption problem, but the solution was an adaptation, not an adoption. So that'll make more sense later. Anyway, to sum up, I think there were two big challenges that any tool that wanted to be widely adopted faced during this time. And only Sisyphus happened to be well adapted to both of them, more or less by accident. So I'll describe each challenge in turn, and then in the last part of the talk, I'll go over how Sisyphus adapted to those two challenges in ways that the others couldn't. Okay, so if you're not from America or England or an English-speaking country, you may not know about Alice in Wonderland. It's a 19th century children's book that's famous in English-speaking countries for its imaginative paradoxes and language and logic. And in the sequel, for example, there's a chess piece named the Red Queen who has to run as fast as she can just to stay in the same place. And the Red Queen has become a metaphor in science and literature, and it also captures this first challenge of any tool that I'm about to describe. It captures what SRE at Google was like in the years 2007 and 2008. So in 2007, there was a cynical joke making the rounds in Google SRE, which was that SRE was really a pyramid scheme. So you applied and you got in thinking now you're going to do really interesting, challenging work, and instantly you were hit with toil for an entire year. And you just had to wait until you were allowed to finally go on call, and then maybe you would get some free time to actually do the interesting work you'd come to Google to do. So this was particularly pronounced in the search SRE team. So they had a tool that I'm just going to call Munchkin because I don't think I'm allowed to use the code name. I just made that up. And I'm just going to give you one example here of this kind of back-to-back toil. So the rollout of a version of Munchkin could take weeks of back-to-back work because each rollout was so huge. And dozens of them had to be completed until it had been finally rolled out to the entire planet. And there was lots of toil, and it was very demanding, but it was high-skill toil. Basically interpreting dashboards differently, correctly, knowing how to roll back from any point. So I'm just going to give you one example of the many complexities that were faced in a single rollout, and that's load testing. So first of all, of course, they would do just a 2x load test to make sure the thing didn't fall over, because the idea was if it can survive a 2x load test, then it's not going to cause a cascading failure by failing over to the next one, which would fail by failing over to the next one. But that wasn't enough. So this was of a kind of search engine, and they also had to test the caches because this code was basically a large graph of leafs and nodes. And depending on what might fail, and always did, because machines always fail, whether it was a leaf or a node, the cache would start serving up results until something had failed over to replace it. And the cache would have different content depending on whether a leaf or a node or something else had failed. And so as part of the rollout, they had to test all these different possibilities and test not only that the cache served correctly while the thing was out, but that the cache got refreshed correctly when the thing was brought back up. So just a lot of work. It's always a very long day. And it was really stressful. The reason it was stressful was because at this time, Google didn't have enough data centers. And so they often had to do these rollouts like in the evening or on weekends, because otherwise Google would have run out of capacity, all of Google. That's how big this was. So it's a lot of hard toil at odd hours, grueling. That's 2007, 2008, being an SRE at Google. So a program, one team, not an SRE, but in a different org, decided to solve the rollout problem for 80% of Google, and they called their program Release It Now. And one engineer from Search named Ed Pitsey decided to just go and join them to make sure that the tool would actually work for Search for the last 3 months of the development, which turned into 6 months. And what he found was that this tool had an excellent design, but it just had too many assumptions that showed that the engineers were not familiar with being an SRE. So, for example, it assumed that a binary to a single data center would take only an hour to push. Took an entire day for them. It assumed that testing was simple and quick, as I've just shown you, it was anything but. It assumed that the order in which you pushed binaries didn't matter. It mattered a lot in Search SRE, and so on. And so after about 6 months, he came back to Search SRE empty-handed, saying we just couldn't refactor it. There were just too many assumptions baked in. A problem of a software tool not being written by SREs. And when he came back in December of 2018, something else happened. A sort of successor to Munchkin was dumped on the Search SRE team, which had the same capacity demands as Munchkin. So in other words, their toil workload doubled, but the number of SREs didn't change, and the number of data centers at Google didn't change. So this was now, before they were like the Red Queen having to run as fast as they could just to stay in one place. Now it was like the Red Queen with their hair on fire. And I'll just stop this. This is when they started building Sisyphus, but the point is, this is one of the huge challenges that any tool that wanted to be widely adopted would have to overcome, because all teams faced similar problems. So any tool was going to have to be something that you could use with the Red Queen with their hair on fire. So that was challenge number 1. Okay, challenge number 2, in Cursive Autonomy. So SREs at Google do share a common culture. It's like very meritocratic, very can-do driven and so on, but oddly, different teams do similar work in radically different ways. And they're kind of prickly about being told that. They don't take criticism well. And SREs know this. One SRE described to me, he moved from London to Boston, and he said it was like going into the Star Trek mirror universe. Like everything was the same, but it was totally different. So let me give you an actual example of this, just one. I have lots of them in the history, but so the example is Search SRE and Traffic SRE actually diverged from the same team, but they evolved really different practices. Search pushes the binary, and once everything is the way it's supposed to be, then they commit the configuration to source control. Traffic SRE starts by committing what they want to have in production, the configuration, into source control, and then they push it. And as far as Search SRE is concerned, this is tantamount to sacrilege. And to quote one of them, he said, if you thought the other team was wrong, you didn't try to convince them. You didn't want to criticize them and make them mad. What you wanted to do was let them do it their way, but continue to do it your way. And this is a common sentiment throughout SRE. So what I'm going to argue is that it's autonomy in SRE which explains this diversity. So first I'm going to give you some examples of just how much autonomy there is in Google SRE teams and many dev teams as well. So first, some personal evidence. So I'd been like a dev engineer, like writing lots of Java for travel for many years, and then I get rotated to this SRE team in San Francisco. And I'm not going to tell you what they were in charge of because that would scare you. But the experience was, after I'd been there a short while, I realized it was as if this team had been hired. It was like half a dozen people. And the same day, Larry and Sergey, the founders of Google, had showed up with a bunch of keys and said, "Welcome to Google. There's the stuff that Google totally depends on. Just figure it out and make it work. Here are the keys. The micro kitchen is down the hall on the left. Welcome to Google. Never see you again." That's how much autonomy this team had. And for example, at Google, we work with OKRs every quarter. What is it? Objectives and key results. Well, in these meetings, the SREs would decide what the OKRs were, and the project managers would just sort of hustle to keep up. Oh, that's what we're going to do? Okay, yeah, okay. That's how driven they were. That's how much autonomy that this team had that I visited. There's also there's non-personal evidence of this. So in 2017, I think it was, there was a postmortem written by an SRE team. What had happened was that a dev team had invited the SRE team to work with them on some product. And after a few months, the dev team just said, we don't want you. They just had a nasty divorce. It was very sudden. And so the SRE team wrote a postmortem to try and figure out what had happened. And they'd never met me. They didn't know that I was working on this theme in the Song of Sisyphus. They found 3 factors, but the main factor they said was autonomy on SRE. So what was going on was that on the SRE team, the engineers would make design decisions. And on the dev team, project or product managers would make the design decisions, I guess because it's about features. And the sort of thing that kept happening was that a dev engineer and an SRE engineer would agree on some design, and then the dev engineer would be outraged to discover that a few weeks later the SRE engineer had changed the design of the stuff that he or she was working on without discussing with the managers. And it would go the other way around as well. An SRE would agree with a dev on what to work on, and then a few weeks later be outraged that like a product manager on the dev team had just changed the design that he had agreed with the engineer. So what happened was the dev team just figured that the SRE team didn't have it together. They were completely disorganized because just the engineers were wild, making their own designs. But actually, all that was going on is that they just had different cultures. In SRE, there's so much autonomy that the engineers do all the designing, and it's different on dev teams. Like, that wouldn't work very well for Gmail if every engineer just decided what feature Gmail should have. Okay, so that's the second piece of evidence for the existence of autonomy. Now, I theorized that it made sense that autonomy could explain this diversity, because if you're given all this autonomy, you become jealous of it, and you don't want people actually telling you what to do because you feel like you're going to take away my autonomy, and that's a nice theory. What about some evidence? So I figured the strongest kind of evidence I could find was for exactly the same pattern happening somewhere else at Google, or even better, outside of Google. And I actually found a place where it happens outside of Google. And that's the SAS, which is the British Special Forces, except it's not at all obvious what makes them special, because they do all the same things that the rest of the regular British Army does. They shoot guns, big guns, small guns, they attack hills, they jump out of airplanes. It's all the same stuff, so what's special about them? Well, what's special about them is autonomy. In the British regular army, if there's going to be some kind of mission, everybody is told how many calories they'll eat, they're being given a certain number of bullets, told what shoes to wear. In the SAS, you're given an objective, the team's given an objective, and then it's totally up to them to decide how to do this. And you can see this emerging already in selection. So getting into the SAS takes 3 months, and in the first month, all you're doing is every day you've got a heavy pack, and you're running alone through this featureless hilly part of Wales called the Brecon Beacons with a map and a compass. And every few miles, you encounter a British officer at a checkpoint. And the British officer, the SAS officer, has only 3 questions for you. He wants to know, he says, show me on your map where you think you came from. Show me on the map where you think you are. Show me on the map where you think you're going. If you get any of those 3 questions wrong, it's over. You're binned. You're sent back to your whatever. But if you get them right, all the British officer does is nods you on your way. There is 0 feedback throughout the day of how well you're doing. Are you ahead on time? Do you need to hurry up? There's nothing, because what the SAS wants is not just endurance athletes. They want people who won't need yelling or a nudge to use this gift of autonomy that will be given to them at the end. So the point is selection alone. This is just one example of the emphasis on autonomy that you can see. So if I was right, this would mean that you would expect to find big differences amongst teams of the SAS, and that is in fact exactly what you do find. So the SAS in any given year is about 500 people. It's divided into regiments, which are divided into troops, and a troop is about the same size as an SRE team, 10 people. And I have an extract from a memoir of this one SAS guy on his second day. He's gone through selection, he's brand new, it's the second day with his troop, and they're doing some sort of jungle trail contact training in pairs. And he's very excited and proud because he thinks he's going to get to show off how he learned everything really well during selection and his training. And he and this guy, Colin, are walking down a trail, and the cardboard contact pops up. And so he fires off 3 shots and then runs back up the trail. Colin empties his entire magazine into this thing, and while pulling out a magazine and putting a new one in, turns around and says, "What the F are you doing?" And our guy says, "That's not the way I was trained to do it." And Colin says, "Oh, for F's sake." And what the guy says in his memoir is what he discovered is that every troop does this sort of thing differently. So the SAS, every troop does differently things that can get you killed really quickly. Shouldn't surprise us if the SRE teams do the same similar things very differently as well. Okay, so that's the curse of autonomy, but I see it as like yin and yang, a blessing. The blessing is when you get given this much autonomy, it's what gives you this enormous amount of drive. You don't have to tell SREs what to do. They're deciding the OKRs. But the flip side is this curse, that different teams become kind of tribal. And so I think the challenge is how to mitigate one while encouraging the other. You don't want to destroy. If you just start telling SRE teams what to do and you take away their autonomy, they're going to be like, "Why am I at Google? Forget this." They'll just go somewhere where they will have autonomy. Okay, so the point here is that any tool that wanted to be like Sisyphus, get adopted by many teams, would have to get around this challenge, because that was stopping all the other tools as well, that different teams didn't want to be told how to do their work. They just liked their own tools and their own ways of doing things. So we get to the end of the talk. How did Sisyphus do it? So first of all, the only languages that were in the running were Java, C++, or Bash, or Python. And I think the Red Queen on fire, especially back then when compiling Java and C++ took much longer, meant that any tool that wanted to get adopted widely was going to have to be in Python. And Sisyphus was. The second thing was that Sisyphus, completely by accident, adapted to this tribalism by having a plugin architecture. So a team would say, well, we can't use Sisyphus because we have our own custom CLI and it can't run it. To which the Sisyphus team would say, no problem. Just write a very thin Python wrapper around your CLI and it's another task in Sisyphus. So what that meant was that a team didn't have to adapt its tools and processes in order to adopt Sisyphus. Instead, they could adapt Sisyphus to the way they already did things. That wasn't always true. Sometimes they had to change a little bit, but they had to change a lot less than for any of the other tools, which essentially said, it's our way or the highway. So Sisyphus wasn't like that. It adapted to the culture. Another thing about it was that it worked well enough. So for example, it would keep blowing out its memory because of the number of things that it had to run, and it wasn't designed with a thread pool. Bad design, but SREs got around it by just spinning up more instances of Sisyphus. Dirty, but it worked. It worked well enough. And remember, the Red Queen with her hair on fire, there's not a lot of time to be elegant. So, and then there was the psychology. So the team also adapted to the tribalism of the psychology. I'll just give you one example. There was this one team that was saying for weeks, just kept coming up with objections about why they couldn't use Sisyphus. And one day, late in the day, over beers, one of the engineers revealed the real reason, and that was that the team was afraid that Sisyphus would put them out of a job. They liked and were proud of the toil, like firefighters, and there wasn't going to be any more toil. And the Sisyphus team thought about this and came up with a way to overcome that objection, so that this team did adopt Sisyphus. What they said was, look, it's unfortunate that our slogan at Google is, for SRE, automate your way out of a job. Really what it should be is automate your way up one level of abstraction, but that doesn't sound as good. So the idea is, think about for years, when Google was founded, SREs would SSH into every single machine. All right, then Google SSH came along, which allowed you to SSH to a whole bunch of machines at the same time. Then came Borg, the predecessor to Kubernetes, where the individual machines just became abstracted away. Now you were just talking about jobs, the software that would run on them. You didn't even see the machines anymore. And then a Borg tool abstracted away the notion of even a single running instance of a binary. It was just like the template for it is all you had to think about, and how many of them there would be. And now Sisyphus was going to allow you to manage jobs across like multiple data centers. Instead of doing everything in one place, you could do it automatically in multiple ones. And who knows what would come eventually, abstracting away to the level of continents or even the planet. The point was, because the internet is so great, demand always surges to fill demand. What did I say? Demand always surges. What is it? Supply. Supply always surges to fill demand. So if an SRE becomes more productive and is now able to do something easily, they're not going to be out of a job, because what's going to happen, it's like the bandwidth of the internet increasing for Netflix. The infrastructure people will just start using more of what you're now able to do so productively. And eventually, it'll become toil and have to abstract away to another level again. And that's how they got. Anyway, the point is, both in its design and in the way the team approached it, they didn't try to change the culture of SRE in order to get this tool to be adopted. Because whenever you propose to a team that they use your tool, you're essentially telling them how to do their job. And I've actually I've overheard a lot of conversations here where people are talking about how to change the culture at their place so it adopts the SRE culture. And I would say, take Sisyphus as both an example and a warning. Trying to change cultures usually ends in tears. Sisyphus is an example of how to adapt to existing culture in order to get people to change. And that's really all I have to say about that. So thank you very much.